estimated bid for electrical work is as follows. Labor costs are estimated to be between $1,500 and $2,500. Material costs are estimated to be between $1,000 and $2,000. The total estimated bid is between $2,500 and $4,500. Note that this is just a ballpark estimate based on the information provided. The actual bid may vary depending on factors such as the complexity of the project, local labor rates, and the availability of materials. Regarding the chimney chase, yes, you can use the chimney chase to run the wire for the subpanel, provided that you follow safety guidelines. Firstly, ensure that the chimney chase is not used for any other purpose, such as ventilation or exhaust. Secondly, make sure that the chase is large enough to accommodate the wire bundle and provide adequate space for bending and pulling. Thirdly, seal any openings in the chase to prevent the entry of moisture or pests. Fourthly, use fire-rated wire and conduit to protect the wiring from heat and flames. Fifthly, obtain appropriate permits and inspections to ensure compliance with building codes. When installing a subpanel, several factors must be considered to ensure a safe and compliant installation. Firstly, you need to calculate the load requirement. Determine the total amperage required for all circuits that will be fed from the subpanel. This calculation should include both continuous and non-continuous loads. Continuous loads are defined as loads that operate for 3 hours or more at a time. The National Electrical Code, or NEC, requires that continuous loads be calculated at 125% of their actual amperage. For example, if a continuous load draws 10 amps, it should be calculated as 12.5 amps for load calculations. Secondly, select the appropriate size subpanel. The subpanel must have a sufficient number of available circuit breaker spaces to accommodate all of the required circuits. It should also have an amperage rating that is equal to or greater than the calculated load requirement. Thirdly, choose the correct wire size. The wire size for the feeder conductors that supply the subpanel must be sized according to the amperage rating of the overcurrent protection device protecting the feeder. The NEC provides tables that specify the allowable ampacities of different wire sizes based on the type of insulation, the ambient temperature, and the number of current-carrying conductors in a racewire or cable. For example, NEC Table 310.15b16 is commonly used to determine the ampacity of conductors. Fourthly, install the subpanel correctly. The subpanel must be installed in accordance with the NEC and all local building codes. This includes properly grounding the subpanel, bonding the metal enclosure, and ensuring that all connections are made securely. Fifthly, use appropriate overcurrent protection. Each circuit in the subpanel must be protected by an overcurrent protection device, such as a circuit breaker or fuse. The overcurrent protection device must be sized according to the amperage rating of the circuit conductors. For example, a 14 American wire gauge or AUG copper conductor is typically protected by a 15 amp circuit breaker, while a 12 AWG copper conductor is typically protected by a 20 amp circuit breaker. Sixthly, label all circuits clearly. All circuits in the subpanel must be clearly labeled to indicate the loads that they serve. This will help to prevent confusion and make it easier to troubleshoot problems in the future. Seventhly, obtain the necessary permits and inspections. In most jurisdictions, it is necessary to obtain a permit before installing a subpanel. The installation will also need to be inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. When running wire through a chimney chase, there are additional considerations to keep in mind. Firstly, ensure the chase is suitable. Verify that the chimney chase is structurally sound and free from any obstructions or debris. It should not be actively used as a flue for any combustion appliances, as this could create a fire hazard. Secondly, use appropriate wiring methods. Use a wiring method that is suitable for installation in a concealed space and that is protective from physical damage. This typically means using conduit, such as electrical metallic tubing or IMT, or rigid metal conduit, or RMC, to enclose the conductors. Thirdly, provide adequate support. Support the conduit or cable at appropriate intervals to prevent it from sagging or becoming damaged. The NEC specifies the maximum spacing between supports for different types of conduit and cable. Fourthly, seal penetrations. Seal any penetrations through the walls or floors of the chimney chase to prevent the entry of moisture, rodents, or other pests. Use a sealant that is suitable for use with electrical materials and that will not degrade over time. Fifthly, maintain separation from other systems. Keep the electrical wiring separate from any other systems that may be located in the chimney chase, such as plumbing or gas lines. This will help to prevent damage to the wiring and reduce the risk of electrical shock. For the specific installation described, the following additional considerations apply. Firstly, the 12 fluorescent lights on 4 switches will require careful planning to ensure that the load is evenly distributed across the circuits. Each switch should control a balanced number of lights to minimize voltage drop and prevent overloading any one circuit. Secondly, the outlets every 4 to 5 feet will require a significant number of branch circuits. The NEC specifies the maximum number of outlets that can be served by a single 15 amp or 20 amp circuit. This is typically based on the square footage of the area being served. Thirdly, the 4 air conditioning lines will each require a dedicated circuit. Air conditioners are typically high amperage appliances that require their own dedicated circuit to prevent overloading the circuit and causing a fire hazard. Fourthly, the 4 dedicated 20 amp circuits for big copy machines and computers will also require careful planning to ensure that the load is evenly distributed across the circuits. These devices can draw a significant amount of power, so it is important to ensure that the circuits are not overloaded. Fifthly, the 4 smoke detectors can typically be connected to a single 15 amp circuit. Smoke detectors are low amperage devices that do not require a dedicated circuit. However, it is important to ensure that the circuit is not overloaded with other loads. When calculating the load requirements for the subpanel, it is important to consider the demand factors that are allowed by the NEC. Demand factors are percentages that can be applied to the calculated load to account for the fact that not all loads will be operating at the same time. For example, the NEC allows a demand factor of 100% for the first 10 kilowatts of load and 40% for the remaining load for dwelling units. However, demand factors are not typically allowed for commercial installations. The choice of wire type for the subpanel feeder conductors will depend on the specific application and the environmental conditions. Common wire types include THHN, THW, and XHHW. THHN wire is typically used for dry locations, while THW wire can be used in wet or dry locations. XHHW wire has a higher temperature rating than THHN or THW wire and can be used in high temperature applications. The size of the conduit used to protect the feeder conductors will depend on the size and number of conductors being installed. The NEC provides tables that specify the minimum conduit size for different numbers and sizes of conductors. The conduit must be properly supported to prevent it from sagging or becoming damaged. The overcurrent protection device for the subpanel feeder conductors must be sized according to the ampacity of the conductors. The overcurrent protection device must also be of the correct type for the application. Circuit breakers are typically used for residential and commercial applications, while fuses are typically used for industrial applications. The grounding system for the subpanel must be installed in accordance with the NEC. The grounding system must include a grounding electrode conductor that is connected to a grounding electrode, such as a ground rod or a water pipe. The grounding system must also include an equipment grounding conductor that is connected to the metal enclosure of the subpanel and to the grounding terminals of all receptacles and equipment connected to the subpanel. The bonding system for the subpanel must also be installed in accordance with the NEC. The bonding system must connect all metal parts of the electrical system together to create a low impedance path for fault current. This will help to protect people from electrical shock in the event of a ground fault. The labeling of the circuits in the subpanel is very important for safety and convenience. Each circuit should be clearly labeled to indicate the loads that it serves. The label should be durable and easy to read. The use of a circuit directory is also recommended. A circuit directory is a list of all of the circuits in the subpanel along with a description of the loads that they serve. The circuit directory should be located near the subpanel so that it is easily accessible. Obtaining the necessary permits and inspections is essential to ensure that the subpanel installation complies with all applicable codes and regulations. The permit process typically involves submitting an application to the local building department along with a set of plans showing the proposed installation. The inspection process typically involves a visit from a qualified electrical inspector who will verify that the installation complies with all applicable codes and regulations. Remember to consult the National Electrical Code, or NEC, and local building codes for specific requirements and regulations regarding electrical installations. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. For the 12 fluorescent lights, consider using energy-efficient LED fixtures. LED fixtures consume significantly less energy than traditional fluorescent fixtures and have a much longer lifespan. This can result in significant cost savings over the life of the fixtures. For the outlets, consider using temper-resistant receptacles, or TRRs. TRR have a built-in safety mechanism that prevents children from inserting objects into the receptacle slots. This can help to prevent electrical shock injuries. For the air conditioning lines, consider using surge protection devices, or SPDs. SPD can help to protect the air conditioners from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, or other events. For the dedicated 20 amp circuits for big copy machines and computers, consider using isolated ground receptacles. Isolated ground receptacles have a separate grounding conductor that is isolated from the metal enclosure of the receptacle. This can help to reduce electrical noise and improve the performance of sensitive electronic equipment. For the smoke detectors, consider using interconnected smoke detectors. Interconnected smoke detectors are wired together so that when one smoke detector detects smoke, all of the smoke detectors in the building will sound an alarm. This can help to provide early warning of a fire. The total load calculation for the subpanel should include all of the loads that will be connected to the subpanel, including the lighting, outlets, air conditioning lines, copy machines, computers, and smoke detectors. The load calculation should also include any future loads that may be added to the subpanel. The subpanel should be sized to accommodate the total calculated load. The wire size for the feeder conductors should be sized according to the ampacity of the overcurrent protection device protecting the feeder. The NEC provides tables that specify the allowable ampacities of different wire sizes based on the type of insulation, the ambient temperature, and the number of current carrying conductors in a raceway or cable. The conduit size should be sized according to the number and size of the conductors being installed. The NEC provides tables that specify the minimum conduit size for different numbers and sizes of conductors. The overcurrent protection device should be sized according to the ampacity of the conductors. The overcurrent protection device should also be of the correct type for the application. The grounding system should be installed in accordance with the NEC. The grounding system should include a grounding electrode conductor that is connected to a grounding electrode, such as a ground rod or a water pipe. The grounding system should also include an equipment grounding conductor that is connected to the metal enclosure of the subpanel and to the grounding terminals of all receptacles and equipment connected to the subpanel. The bonding system should be installed in accordance with the NEC. The bonding system should connect all metal parts of the electrical system together to create a low impedance path for fault current. The labeling of the circuit should be clear and durable. Each circuit should be labeled to indicate the loads that it serves. The circuit directory should be located near the subpanel so that it is easily accessible. The permits and inspections should be obtained before starting the installation. The installation should be inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. Ensure all work is performed by qualified personnel adhering to local codes and regulations.